This is Euclid Book 5, proposition number 22, and what we're going to talk about today, well, I tell you, Euclid definitely has a sense of humor. He says, if there be any number of magnitudes whatever, and others equal to them in multitude, which taken two and two together are in the same ratio, they will also be in the same ratio ex equali. Yeah, this is going to be fun. Okay. He says, let there be any number of magnitudes A, B, and C. Well, we got an A here, we got a B here, we got a C here. There's A way up here. See? A, B, C. Alright, and then he says, how about, we'll take another three magnitudes, D, E, and F. Okay? Here's D, here's E, there's F. Okay. And it says, let there be any number of magnitudes A, B, and C, and D, and others D, E, and F equal to them in multitude, which taken two and two together are in the same ratio, so that as A is to B, so is D is to E, D is to E. Okay, and as B is to C, B is to C, so is E is to F. Okay, so far, well here. As A is to B, D is to E, as B is to C, so is E is to F. So far, so good. Now, and I say there will also be in the same ratio ex equali, that as A is to C, so is D is to F. So as A is to C, so as D is to F. Okay, and I think that's what he's trying to prove. Alright. Now, for of A and D, let equal multiples G and H be taken. Okay? So we have lines A and D here. Okay? And what we're going to do is we're going to have G, okay, G here is going to be double of A. G is going to be double of A. And, of course, H is going to be double of D. So you got D here, and H is double of D. Now, before we go on here, I wanted to tell you how this is going to all pan out here. A is going to be a 1/4 inch. B is going to be a 1/2 inch. D is also going to be a 1/2 inch, and E is going to be 1 inch. Now, we've already established that B is going to be a 1/2 inch, C is going to be 1.5 inches, E is going to be 1 inch, and F is going to be 3 inches. And that you have to do this, or this thing's not going to work out right. Okay? Now, I'm sure you can plug in other numbers, but the thing is, if you plug in other numbers, you're going to draw big, big lines at the end, and you're going to run out of paper space unless, of course, you take a great big paper and you draw it out outside. You go outside and you draw this thing all out, and that would be a big pain in the royal tushy. But you do what you like. Okay? So we're going to use real small numbers to illustrate this. That way we can actually fit it on the paper. Alright. We're going to have B, and K is going to be triple of B. K is going to be 3 times the size of B. Here's B up here. See, there's B up here. K is going to be triple that. So, we've already established that B is 1/2 inch, so K is going to actually be 1.5 inches. Alright, and E, way up here, here's E. Now, L is going to be 3 times the size of E. Well, here's L, and it's going to be 3 times the size of E. Now, E is 1 inch, so L is going to be 3 inches. So far, so good. Now, we're going to go on to C here. Well, here's C, and we're going to have, hang on, C, okay, M is going to be double the size of C. Well, here is M, and it's going to be double the size of C. And N is going to be double the size of F. Well, here's F, and M, or N here is going to be double the size of F. Okay. Then, since A is to B, so is D is to E. As A is to B, so is D is to E. Okay. And of AD, equal multiples GH have been taken, which we already established that. And of BE, other chance equal multiples K and L, we've already established that. Therefore, as G is to K, as G here is to K, so is H to L. H to L. So we have a ratio of G to K and a ratio of H to L. And this is by Euclid Book 5, proposition number 4. For the same reason, as K is to M, okay, as K is to M, so L is to N. L is to N. As K is to M, L is to N. So far, so good. Since there are three magnitudes, G, K, M, and others H, L, N, equal to them in multitude, which taken two together are in the same ratio, therefore, X equali, if G is in excess of M, okay, let's see here, is G in excess of M? No. Okay. H is also in excess of N. However, if G is less than M, if G is less than M, okay, which in this case G is less than M, H will be less than N. H will be less than N. As you can see, H is not nearly as big as N. And so therefore we've met the requirement, and this is proven by Euclid Book 5, proposition number 20. And G and H are equal multiples of A and D. Okay? G is an equal multiple of A. H is an equal multiple of D. And M and N are equal multiples of C and F. M is an equal multiple of C. And N is an equal multiple of F. Therefore, as A is to C, so is D is to F. As A is to C, so as D is to F. And this is by Euclid Book 5, definition number 5, so on and so forth. I think you finally get the picture here. Alright, and that's Euclid Book 5, proposition number 22. I hope you enjoyed it. There are only 3 more proofs until we prove the Greek letter sigma. Stay tuned.